Hi students, good evening to all of you. Today we are going to discuss about S block elements, periodic trends. I am giving a simple tricks. If you follow this, it is very easy to answer the objective questions which you may confuse if you normal preparation. I am giving a simple excellent tricks, you just follow it. Yeah. So here first one, the important trend is thermal stability, solubility and melting point. First of all, we will do this one. Thermal stability. Thermal stability of metal hydrides, first A group elements, is decreases, right? Next, thermal stability of metal hydroxides is increases, and the second A group elements, thermal stability of second A group element metal hydroxides also increases, right? Next, thermal stability of metal carbonates, that is M2CO3 metal carbonates increases, and second A group elements metal carbonates, that is MCO3 also increases. Next, thermal stability of metal bicarbonates increases. Okay, for second A group elements it is not given. Okay. Next, thermal stability of metal nitrates increases. Next, thermal stability of metal oxides, that is superoxides, is increases, that is potassium, rubidium, cesium superoxides. Progressive increases, but lithium, sodium cannot form superoxides. Take care. Okay, fine. Next one. Next, solubility now. Solubility. Solubility of metal hydroxides, first A group elements, metal hydroxides, is progressively increases, and second A group element hydroxides also increases. Next, solubility of metal carbonates M2CO3 is increases, but for second A group elements carbonates it is progressively decreases. Solubility of second A group element sulfates decreases. Solubility of metal fluorides increases. There is M is first A group element, lithium fluoride into cesium fluoride, solubility increases. Next, solubility of metal iodides is decreases, right? Next, solubility of metal fluorides to metal chlorides of second A group elements increases. Fine. Next one, melting point. Melting point. Melting point of first A group elements, that is lithium to cesium, it is progressively decreases because metallic bond strength is progressively decreases, because here only one electron is participate in the metal bond formation, right? Next, second A group elements, that is from beryllium to barium, also decreases melting point. Okay. Next one, melting point of metal fluorides to metal iodides, it is progressively decreases. Metal fluorides to metal iodides Next, melting point of metal fluorides to metal iodides of secondary group elements decreases, right? Okay, this is melting point trends. Next one, hydration. What hydration energy or hydration enthalpy? It is inversely proportional to size of the cation. Size of cation. Right. So hydration and hydration energy of first year group elements in aqueous solution. Hydration means when the metals are get dissolved in water. The aqueous solution. Right. In the aqueous solution, the hydration and hydration energy of hydrated metal ions. So lithium is occupied by more number of water molecules. So that's why lithium hydration and hydration energy is more. If more number of water molecules accumulate, okay, so then the more amount of energy released where? When the metal is dissolved in water. Hydra means water. So when one mole of element or salt is get dissolved in water, during soluble, the released energy is called hydration energy. So this is inversely proportional to size of the metal cation in water. So that's why the lithium aqueous, that is hydrated ion, is larger in size and this progressively decreases from lithium ion to cesium ion, hydrated ion, right? Progressively decreases. Then the same thing for secondary group elements also. That is for beryllium ion, hydrated ion, to barium hydrated ion. The hydration and hydration energy progressively decreases. Then mobility or conductivity. That means in case of lithium, more number of water molecules accumulate. That's why it is heavy now. It moves slowly. That's why mobility of lithium ion, hydrated ion, and conductivity is less, right? So there is this progressively increases cesium, hydrated cesium ion is more conductivity, more mobility, right? It is fastly moves because of less number of water molecules are surrounding accumulate. Yeah. So let's start now. So lithium, hydrated lithium ion, conductance and mobility is less, and the cesium ion is more. That is, from lithium to cesium, hydrated ion conductance and mobility increases, right? Yeah. The same thing is applied for secondary group elements also. That is beryllium to barium, hydrated ion, mobility and conductance increases. Right, my dear students, got it? Yeah. This is very important, my dear students. Hydration and hydration energy and size of the hydrated ion and mobility of the hydrated ion, conductance of hydrated ion is we have to keep in our mind. Next one, the liquid ammonia solution. When the metal is get dissolved in liquid ammonia solution, right? Then the color and magnetic property is very important. See, for example, a first year group element this get dissolved in liquid ammonia. You have to take X plus Y moles of liquid ammonia into which the first year group or second group metal is get dissolved. Then what you will get? You will get the metal loses electrons. The electrons are surrounded by ammonia molecule and metal ions. When the metal loses electrons for metal ions, the metal ions are surrounded by X number of ammonia molecules, and the electrons are also surrounded by Y number of ammonia molecules, Y moles. That is here you just represent it is that is X plus Y moles of liquid ammonia. You take it here. The metal loses electron. The metal ion is surrounded by X moles of ammonia. and electrons are surrounded by Y moles of ammonia. These are called ammoniated electrons. This is a single electron, right? So these ammoniated electrons responsible for blue color of the solution. You know, unpaired electrons are responsible for color and magnetic property, paramagnetic property. That's why these ammoniated electrons responsible for blue color of the solution, and these electrons are responsible for paramagnetic property of the solution. Paramagnetic property, my dear students. Paramagnetic means just little attraction, because each electron is behaving as a tiny magnet, right? Then, if this same solution is get dissolved, it is just leave it for some time, you just stand it for some time, okay? Then what happened? That metal ion is gain electrons and combines with the ammonia molecules, then become into metal amide, soda amide like that, NaNH like that, and it releases H2 gas, right? H2 gas, half mole of H2 gas. See, the metal, it gains this electron, and NH2 minus will get on H plus. That M plus combines with NH2 minus. Here M plus, the metal carrying positive charge, and it combines with NH3. It is disordered as, you will get NH2 minus and H plus. M plus combines with NH2 minus, you will get MnH2, and that H2 minus gain this electron and become into H2 gas, half mole of H2 gas, that is one hydrogen, right? So then because of formation of this MnH2, that is the concentrated solution. Concentrated means it will stand for long time, it will become concentrated, then forms metal amides. Then the color changes from blue color to bronze color. Blue color to bronze color. The changing of color is due to formation of metal amides. And magnetic property, no, free electron is not there. Ammoniated electrons are not there. So that's why it become into diamagnetic. It become into diamagnetic. Is it clear, my students? So these points are very important related to trends of S block elements. Is it clear? Yeah, this is first one, thermal stability. Most to focus on thermal stability and solubility. You have to keep this points in your mind, keep care, okay? And then melting point, then hydration energy. This is most important. If you come across the previous year question papers, from that questions are appear, then this solution in liquid ammonia, that is the elements when they get dissolved in water, the formed solution in liquid ammonia having a blue color, and it have paramagnetic property. Understanding, it changes metal amides by gaining electron, and it have bronze color and diamagnetic. Is it clear? Yeah. Fine, ma. I think you enjoyed this video. Like it, subscribe it, and share to your friends. Thanks for watching my video, my dear students. Fine.